Next, we will make a plot of the axial velocity along the outlet along here. The first thing I need to do is create a location, quote unquote location, that is a line corresponding to the pipe outlet. To do that, I go under location and I select line. So that'll help me create a line corresponding to the outlet. And so I will call this pipe outlet and I will click on OK. And so the starting point, so here I specify the start and the end points of the line. The starting point is 8, 0, 8 being the length of the pipe that is being simulated, and point 2 is 8.1, point 1 being the radius of the pipe. And I'll click on apply. And that creates a location. So if I zoom in here using the right mouse button, I can see that there is a line, and this is a little misleading because we have stretched this plot. So what I'll do is I'll turn off velocity magnitude and I'll turn on the wireframe, and I can see that indeed the line that I created corresponds to the pipe outlet. So now I can plot the axial velocity along this line, and to do that I go under chart and I click on the chart icon and I'll call it velocity profile. Okay. And that goes into the chart viewer. Until now we were in the 3D viewer, but to view charts you go under the chart viewer and it goes there by default. And so under data series, okay, so click on details of velocity profile data series. Under location you see the location that we created appears. And if we didn't create that location, we wouldn't have a location to make the plot over. So that's why we needed to create the location first. Okay, and x-axis, which is we're telling it, hey, what to plot along here. And we want it to plot the axial velocity, so which is velocity u. And y-axis, so here we tell it what to plot along here. And I will ask it to plot, use the radial distance. So y is the radial distance, if you recall, for an axisymmetric problem. And I click on apply. And so I get the velocity profile at the outlet, and here you can see, this is a very coarse mesh. And you can customize the title and this, the legend name and so on. But probably the easiest thing to do is to export the data into Excel and do further processing in Excel or MATLAB. And to export the data into Excel, I click on Export. And I go to an appropriate folder. I'll go to my working folder. And I already was testing this, so I have this thing called outlet profile, but you will have to enter it. Okay, and it'll automatically save it as .csv, which is comma separated values. You won't get this because you don't have that file. And if I go into my working folder, I will see the, the file that was just created, and if I double click on it, it'll open it in Excel, and I'll see that I have the data, the radial distance, velocity, axial velocity versus radial distance. And now I can compare this to the the fully developed profile that is expected from analytical results.